All right, we're going to talk about power tools today, and we're going to introduce you to some of the power tools that you might see in the woodworking shop. So if you'll buckle up and pay attention, we'll cover these, and hopefully when we're done, you'll have a better understanding. We have three different drills in the shop that we're going to talk about. And the first one we're going to look at here, this is our cordless drill, and it's easily identified by the battery pack that's usually on the bottom of the unit. The cordless drill has the most settings that you can adjust. So there's a forward and reverse, there's a high, medium, and low, or a high and low, depending on the unit. And then there's this clutch around the outside where you can set the torque to different settings so you don't strip out screws and things like that, depending on how hard of material you're screwing into. So this is the cordless drill. The next one we're going to take a look at is our right angle drill. Now, the right angle drill can be identified by the short, stubby little head. You can see that this size is much smaller than this unit, so we're going to be able to fit into a much tighter area than we would be able to with the cordless drill. This one is also battery powered, so the right angle drill is also cordless, but there's less settings. It has high and low and forward and reverse, but no clutch on the chuck head that you see like this one. They're both keyless chucks, but it doesn't have the clutch like the cordless one does. But it does have this ability to get into a really tight, narrow spot. So that's the right angle drill. The last one we're going to look at, this is called our electric drill. Now this one's benefit is it has a cord that you would plug in. You have unlimited power. The only thing you're limited by is how much torque or turning power the motor can create. Where this one here, you have only the amount of power that the battery has contained in it. So if you're running on half battery, you may not have as much power, where this one you're going to have full power all the time. Now, the downfall to this is you're on a leash. You only have a cord that is so long, and so you have to be within a certain distance to an electrical outlet for this to work. You'll notice that there's not as many options on this. There's no clutch like we see on the cordless drill. And then as well, there's only a forward and reverse with the little trigger down here. And then you can pull on this for variable speed. All three of these are variable speed, meaning that you pull the trigger. The harder you pull the trigger, the faster it's going to go. The lighter you pull the trigger, the slower it's going to go. So these would be the drills you should be familiar with in the shop. Now let's take a look at some other tools. These are going to be some accessories on the drills. Now, I mentioned that those drills had keyless chucks. This is a keyless chuck here. You'll notice that there's just these little grippies where you can hold on with one hand and then hold the other section with the other hand. And so this is a keyless chuck versus a chuck that looks like this with these little splines all the way around. This would be a keyed chuck. And the keyed chuck is going to require you to have a chuck key, which is this here, and this is what you're going to use to tighten and loosen your bits into the chuck. And that fits into these little holes. You see these holes around here, and the key fits in, and you can tighten and loosen that to get these jaws to open up. So the downfall is that you have to have this key. The benefit is that you can tighten these bits super tight, where these bits, you can only tighten it as much as you can get your hands gripped on those two collars. So they both have benefits and drawbacks, but most of our drills and most modern drills that you see are keyless chucks. You see the keyed chuck still on some more industrial type machines. You might find a keyed chuck. We have a keyed chuck for our wood lathe if we need to drill holes while we're turning. So some different drill bits we should be familiar with. This is your standard drill bit. It's called a twist bit, and it just has these flutes that are twisted around the shank of the drill bit, and there's a tip on the end for cutting. Okay, the angles can vary on the tip, but you just need to know that this is a twist bit. This one here is going to be called a brad point bit, and the brad point has this really sharp tip on there, and it's going to allow you to not walk when you start to drill. When we talk about the bit walking across the surface, if we take a look at our regular drill bit, there is no sharp point on the end, and so there's just a little bit of a high centered spot depending on the angle of the bit. And if this is our goal to drill a hole here, if I don't have much downward force, as I start drilling, that bit can start moving or walking across the surface. And then when my bit does catch, I may find it that I am no longer on my mark, that I've missed the mark because the bit walked across the surface. The walking occurs because when I start, and the rotation of the bit causes it to move across the surface. It's not catching or biting into the workpiece, and so then it just moves across the surface until it does catch. This brad point will help eliminate that because it's not going to walk. You're pushing this in, this tip is going to be secured and it's not going to move around. This, unfortunately, isn't used for metal, so it's not going to help with bits walking across metal. It's really just for wood. This type of bit here, this is called a Forstner bit. Usually has these serrated teeth around there, has this kind of a line in the middle that has a sharp edge that's removing the bulk of the material. So that's a Forstner bit. This is called a spade or a speed bit, most often referred to as a spade bit, and it's kind of just a flat paddled bit, and it's got this sharp point on there. Again, it's not going to walk. Either one of these have a point on them, so they're not going to walk as you start to drill. They're going to hopefully stay in one place and not walk across the surface. And this is just going to chew out the material really fast, hence it might be known as a speed bit depending on who you talk to. And it's going to get through that material really quickly. It's probably not going to be the most clean cut hole of the different bits that we have. It's probably going to be the one that's most chewed up and the inside's maybe a little bit more rough. A few other bits that we're going to be familiar with. The first here is what we call a countersink bit, and it's got a chamfer on the end, and it's going to be used to countersink holes so that screws can be set at or below the surface. We've talked about these already in class, but a countersink bit has this taper, kind of comes up to a point so it can create a chamfer around the hole. This is also a style of countersink bit, but this one is going to pre-drill a hole big enough for the tip of the screw, and then it usually gets bigger for the shank of the screw so it can freely move between the wood, and then ultimately down here at the bottom is a countersink. So either one of these will do the countersink action. This one you have to pre-drill a hole first. This one is going to pre-drill the hole and countersink it at the same time. This last one here is called a hole saw. It's also got these serrated teeth. They're a little bit more serrated than the one we saw in the Forstner bit. It's got this small drill bit in the middle, and this is just a pilot hole to keep it so that as this big hole is turning, or this big bit is turning, it doesn't move and walk over the surface. So this pilot hole bit is going to be what kind of guides it and keeps it from walking all over the material. So a hole saw. The downfall of a hole saw versus a Forstner bit is the hole saw is going to be left with a piece of wood in the middle. The circular part that you cut out is going to be stuck in the middle, and you have to wedge it out by sticking something in here, typically a screwdriver, and kind of wiggling it from each side until eventually that disc pops out. So there is a negative effect with the hole saw that you have to get that wedge out, but the benefit is they come in really large sizes, 4, 6 inch, when you're doing duct work and things like that, that you may need a big hole drilled. So routers. Next, we're going to talk about the routers, and we have a couple different things we're going to talk about. The first is the one that we see in class. This is our fixed base router, and it is a fixed base, but specifically it has a T-style handle, right? So one hand goes on each one of these, and it kind of looks like a letter T. So that's where it gets its name, T-style handle. But it's fixed. It's not going to, when you're cutting, the bit is not going to be moving up and down like it would in some of our other routers. This router here is also a fixed base, but it has a D-style handle. So the D-style handle, just a little different setup. Your on-off switches with this trigger. You don't have to use the switch underneath the lip like that. But this D-style maybe just gives you a little bit more control. It's just really personal preference when you're routering which style you like. Either one is fine in my opinion. I've used them both. Now this here is a base that will work on the motor for these routers. And so this is a plunge base that allows us to plunge up and down while we're cutting. And this will work on our standard router. Now this is a little different than a plunge router itself, which is like this one here. We also have this in class, and the plunge router is a bigger unit, and the base doesn't come off, right? So the base is fixed on here. We can't change it, but we can pull it down and lock it and use it just like a fixed base router. So really, if you had to come and buy just one of these, you can buy these in a kit and get the fixed base and the plunge together. But if you had to buy just one style of router, the plunge router or a plunge base would offer you more versatility than a fixed base router would. You can do more with the plunge router. The plunge router can do everything this can by locking the base down, and but it does plunge up and down and move on these cylinders that are there. So those are our routers you should be familiar with: a T-style, the D-style handle, the plunge base, and then a plunge router itself. So some router bits. Now there's 3 different style of bits we're going to look at. The first one here is a router bit with a bearing on top. This is kind of like your iconic looking router bit. There's no mistaking whether this is a router bit or a drill bit because of that bearing, the guide bearing on the top. So this is a router bit with a bearing. This next one is without a bearing, and it has nothing to guide the cut. So the bearing is going to keep the board from going too far into the wood and just going all over, where this one is not. This one's going to be controlled in like a plunge router where you plunge in and make a little V-groove, or you need some kind of fence or straight edge to keep a straight line. So there's no guide bearing on this bit. Now, when we're talking about the identification test, we're going to be looking at one that has a bearing. I don't want you to be mistaken thinking maybe it's a router bit versus a drill bit or something like that. So I want there to be no mistake. You'll see something like this with a bearing. Now, the third kind we might see looks like it has no bearing on the end, but if you look at the other side of the bit down here, there is a bearing on the shank side of the bit. Okay, this is used for like cutting patterns and things like that. Maybe you have a pattern you lay on a board. This will follow your pattern, and then the board underneath your pattern will get cut to the exact size. So those are 3 different options of router bits that you might see or come across in the shop. And again, they come in all different profiles. So the profile meaning the pattern that it cuts. This one's going to be a radius. This one's going to be a 45-degree angle. And this one's going to be just a straight cut. It's going to cut like a dado or a rabbit. All right, let's look at some other spinning tools that rotate. And the first one here is like a little router. This only takes 1/4 inch or 1/8 inch router bits, and it's called a laminate router. This might be beneficial when you're getting into some small, really tight areas and you need to router some fine, precise cuts. The laminate router might be a good choice. Or if you're trimming off laminate, when you're attaching laminate to a substrate and you've got a little overhang, you're making it flush, that's where this really comes in. You're not cutting a lot of material. There's not a lot of pressure on the bit, so it's a lot smaller unit than our fixed base routers. The other one you might see is this variable speed rotary tool. This one happens to be Dremel brand. Dremel is a brand of tool, not a name of a tool. Dremel makes other tools. We've had a scroll saw in here in the past that was Dremel. So they are a tool manufacturer, but it's a variable speed rotary tool. And you can put any of these accessories in. So you can put sanding drums in there and sand different parts. You can put different cutters in. There's grinding discs that you can put on here. There's also little cutting router bits type deals you can put on here. So a wide variety of things you can do with this variable speed rotary tool. So we're going to take a look at our saws, and there's several different saws we're going to be familiar with. And the first one here has a name that sometimes it's referred to that is not its actual name, but a brand name. And some people have referred to this as a skill saw. And if we take a look here, you can see this particular tool is a drill, and it's in the Skill brand. So skill saw would not be its correct name. What its correct name is a circular saw. If we look at the blade, it makes a circular pattern. This is a portable circular saw. And this one happens to be cordless, but they also do come in the corded version. This one up here is called a reciprocating saw. Now, some of you may say, well, that's a Sawzall. And technically, yes, this one is a Sawzall. That is a name that Milwaukee has called their reciprocating saw. So if this was a different brand besides Milwaukee, it would not be a Sawzall. You can see Sawzall and there's a little registered trademark right there. That is the brand name for Milwaukee's reciprocating saw. And then the last one we're going to look at here, this is called a jigsaw. And these two that are linear saws, right, the blade moves in a line motion. On this one, the blade moves in and out. This one, the blade moves up and down. This is a circular saw, meaning the blade spins in a circular pattern. The linear saws are not really going to give us very straight cuts. And so they're going to be for more irregular shapes. And if you think about a jigsaw, right, a jigsaw puzzle usually has all kinds of squiggly edges. And so a jigsaw is going to be able to get in and make those irregular shapes like a jigsaw puzzle has. All right, let's take a look at our sanders. Okay, the two that we're going to look at first are ones that would fit in kind of the palm of your hand, and your hand would rest on top. This first one is the one you're going to use the most here in our shop, and this is an orbital sander or a random orbital sander. Orbital sander indicating that the disc down here spins, random meaning there's no pattern, that it can go either way, it kind of jiggles back and forth, and not necessarily in a perfect rotation all the time. It may just oscillate back and forth or kind of wiggle a little bit. So that's an orbital sander, and again, the way to identify that is with the round disc on bottom, an orbital sander. The next one is a palm sander, and you can see that the head of the unit kind of looks similar to the orbital sander, but the palm sander has a square bottom. It's going to take a piece of regular sandpaper, and you cut that into fourths, and then you load your paper in through these clamps that are down here. So the palm sander has a square bottom, the orbital sander has a round bottom. So next we're going to take a look at our sanders. These are our little bit bigger sanders than the palm and the orbital sander. This one's a finish sander, and it takes a half a sheet of sandpaper, and it fits into these little spring clamps on the front and back side. Finish sander just lightly oscillates or orbits and just vibrates. So as you move this across your wood, it's just lightly vibrating and giving a sanding action. And again, that's a finish sander. The next one is our most aggressive sander, and it's called a portable belt sander. It's a belt sander on a portable unit where we can move around. This is a little different than some of the tools that we've used, some of our stationary belt sanders that we used for some of our previous projects already. This is our portable belt sander. All right, there's a few different nail guns that we're going to use in the shop, and our nail guns are all pneumatic, meaning that they hook up to air power. And this first one, and you can see that they all will have this little spout coming out the back where a coupler will hook into there. This first one is our brad nailer, and it shoots wire brads out of the tip. The brad nailer has a little bit of a head on there. We've talked about the nails already a little bit, but this is the brad nail gun. This one here, they look very similar, and it's hard to tell them apart. When we have these on the identification test, I'm not going to give you both names, but I'll give you a picture and you have to pick one of the two names. So this is our finish stapler. It's a narrow crown stapler, meaning that the crown of the staple across the top of the staple is only about 3/8 of an inch. So it's got a narrower crown than like a stapler that you might staple down tar paper with, or that you might staple even your paper with. That has a wider crown. So a finish stapler, and again, they're hard to tell apart. Really, the difference is down here in this magazine where that holds the fastener. Usually the brad nailer has a wider track for holding longer nails. This last nail gun here is our pin nailer, and it shoots really tiny little pins without little heads. They're just wire pieces that will shoot in and hold things. And we usually use this when one of these two nailers is going to break our piece of wood. So really fine, delicate trim that the brad nailer would crack. Then we will move down to the pin nailer and we'll shoot pins in. The pin nailer is identified is that it doesn't have a tip on there. Like this one has a tip that has to be depressed down here, this orange tip. Well, this one doesn't have anything like that. Its only safety is the double trigger. So you have to pull one trigger before you can pull the other. The head that drives the nail out is also smaller. You can see it's a more cylinder front than these two that are a lot bigger front parts of the gun. So this is our pin nailer. Pin nailer, brad nailer, and finish stapler. This is another tool we're going to take a look at, and this is called oscillating tool, and it can do many different things. So right now in this picture, we see this with a saw blade on there. So it just oscillates back and forth. It's going to wiggle right to left, back and forth, and kind of make a cutting action. Now there's a variety of different accessories that we can put on. We can put some sandpaper grits on here. There's different knives or cutters that we can put on here. We've got some grinding tips that we can put on there for like digging out grout and things like that. So as a versatile tool, can do a lot of different things. And we do have one of these in here for odd things that we just can't cut with a normal saw. We maybe break out the oscillating tool and use that. So just oscillates back and forth. So when it comes to joining material, this is one that we should be familiar with. This is called a biscuit or a plate joiner. And when we use this in class, you'll see, but there's a little saw blade that'll come out of here, and it's going to cut a little half moon shape into our workpiece that'll allow for half of a biscuit to be put in there. Kind of looks like a grinder with a bigger head on there, and then this tongue is what keeps that at the right angle, so the slot is cut, whatever angle. We typically use a 90-degree angle, but you might find a time that you're using a 45-degree angle. But this is our biscuit or our plate joiner. And that's all the tools that you need to be familiar with. If you have any questions on these, please talk to your instructor, and we'll make sure to get your questions answered.